Good morning. Welcome to the last course of the 2024 virtual education for the Virginia Water Well Association. We are excited to have Brock Yordy producing the content of history of drilling and technology for us this morning. Brock has presented lots of content for us in the past and is active in his own family business as well as being a consultant for national drilling publications and offering his service across the nation. So thank you, Brock. We appreciate your time this morning.
Good morning, everybody. Well, I know it's 8 o'clock on a Thursday morning, and I don't know about you guys, but it has been hot here in the Midwest. And I was working in Chicago with some young drillers yesterday and Tuesday and Monday, and yesterday was a little bit cooler, but now it's 70 here, and I'm sure the same thing. So let's get hammering out on this so we can get you all back in the field and get to working where it's not 100 degrees. Uh, we've had a good introduction of me. Yeah, I'm Brock Yordy. You can reach out to me in multiple ways on social. I'm here to help. I have spent since 2009 working with the U.S. military and training new drillers and building drilling programs. I spent almost over a decade with Bayreuth, 5 years with Jeffco as director of R&D. I love this industry and I love experiencing lots of different pieces of it, and that's where I'm at today. So, history of drilling. I have phrased this several different ways as we have talked in early this year, and I've changed it again. But as we talk about what came first, the spring pole or a different type of rotary drill or all of this, you know what? We came first. This isn't a chicken and the egg situation. This is a driller, and then the driller built the drill. And so the earliest evidence of water wells is located in China, and we have some really great written history from 1046 to 771 BC. And what's crazy is in these documents that they've held on to, the Chinese at that time with the empire had processes and methods and guidelines for protecting their groundwater and maintaining their wells with rehabilitation. And we won't see the spring pole method for another, 400-ish years. So as we talk about this, we came first, the driller. And then, of course, we took that cutting torch and that hammer and started creating what we wanted as a drill. When it comes to the first rig technology, this is a big debate that I think is fantastic. As we look at spring pole into cable tool or rotary, what technology came first? And we just talked about China. Well, 4,900 years before we started seeing that first existence of water wells and that history, we have Egypt, 3000 BCE. And the third millennium BC, they were coring, and this is a direct from a archaeological journal. It said, drills hard stone. Well, we can see that drill logs have continued with one trend, and that's it's either a rock or a gravel or a sand or a clay, or hard. But what we found was they were coring quartz and granite. And with all of the history of hieroglyphics and recording that, there's no wall paintings, there's no text that discuss how this happened. So there has been a debate since 1883 between Lucas and Petrie that even as you jump online today and start Googling this, searching it however you want, you will still come across new scholars having a debate over how the heck did they core these holes, 4,900 years ago. And Lucas had stated, and these are the two core debates: copper nor bronze. There's not enough to cut basalt, diorite, granite, quartzite, schist. It must have been a loose abrasive powder fixed to the rods. There's no technology available to create cutter heads. Petrie comes back with wait. We look at all the technology and the weapons and the things that are coming out, how they're cutting stones from the pyramids. And he said cutting of granite was done by jewel fixed cutters with tubular drills. So we're talking modern day core drilling. This is the first existence with fixed cutting points of emery are set in the tube inside and out. So a diamond impregnated bit. This is pretty cool to think about. Again, he states it's impossible that abrasive powder fixed to a rod would withstand the depths. And we have hundreds of meters to 1,000 meter holes that they have found that have been cored this way that have the carbon dating that say that this is a long time ago. So what do we get out of this as drillers? Because obviously we need to get back to the East Coast of Virginia and water well drilling here in the good USA, but it's a lost technology. And how often, as we talk about the history of drilling, and I want you to think about from generation to generation developing equipment, and then we lose something valuable. So the best R&D that we do at the back of our shop, that we go, you know what, this is our secret. Nobody can do it better. Somebody else is doing it, or it's been done a millennium before. But we as an industry need to do a better job of just stop using our hands as hammers, pick up that pencil and start writing down, what has made our company great and successful. So the history of drilling is very much embedded into you. And as we grow this industry, and we're seeing it grow again right now, it's very important. So if the Egyptians, with all of the scholars that are looking at their stuff, we can't figure out exactly how they did it. There's going to be a day when we're going to lose more art as we think a cable tool today and working a walking beam or friction brakes or everything that it took to be able to run a combination rig. Now we can jump to 347 BCE, and we have the spring pole, which is the great granddaddy of cable tool. And you can see they talk about what wood had the best spring, hemlock, and how they shaped it. And we start seeing first examples of this in the late 1600s, early 1700s in Appalachia. And here's some drawings, two individuals working. It's convenient that there was always a tree right there. That's what somebody said. They go, Brock, this is ridiculous. And I go, have you ever considered they saw two good trees and they decided to drill the hole there? And, obviously we go, oh, check our driller ego. That makes sense. Yeah, they found an ideal spot that we could build the spring, and then we put the hole in. And here's another great artist rendering of, early Appalachia. Then we move into steam-powered walking beams. And we see this with Star Drill coming on the map. We see this with Sanderson Cyclone. And really, as we start hearing about steam-powered drill rigs, it was all in Europe. It wasn't until the late 1800s, early 1900s that we got involved. And what's crazy is as you dive deeper and you see when all of these innovations were happening in the 1850s and 60s in Europe, we were fighting a civil war, that both sides, we stopped innovation in industry to solve what we needed to solve in our country. And we lost, 2.5 decades of innovation that was happening around the world while we sought out those issues. So you think about, as we look at water, clean air, environmental policy, the USDA, OSHA, we all know those are bipartisan. We need those. We need to be able to be having good potable drinking water. We need to stop mandatory hookups and that type of thing. So as we see the steam engine powered walking beam, we jump right into what was the first rotary drill rig invented. And obviously what's crazy about doing this on a Zoom and not being able to see you all, I can't see who's going, Brock, come on, get with it. But in reality, the first print drill rig renderings we have, and it's some of the earliest technology. So Leonardo da Vinci, as we think about the war machines he built and the flying devices and everything to aqueducts and everything, what does he build? A drill. Why? Because nothing in our civilization progresses without drilling. So it's really cool to think about as we look at these renderings and you look at his makeup for being able to trip rods and whatnot. And this is a device that you can still see in the museums there in Venice, but it's pretty cool to think about one of our greatest inventors and innovators of humankind. One of the third things he starts drawing is a drill. That's how important we are as an industry. So then we can jump to modern day, and obviously, walking beams and cable tool made sense versus rotary. So we really have to start thinking about what progressed us from there. And I love this cutout. This is Bakersfield, California. This is 1909. Oil field is booming. I want you to think, and we're going to talk about the Lucas Oil Spindletop well at the King Ranch, which gushed early January 1901. But here's Standard. There's right in the front page, Standard adds rotary drilling to Midway Field. And as we blow this up, what I love about this is as you run through and they talk about, 4 of their new rigs are going to be rotary rigs. It says, although it has not been popular with most of the oil operators, the rotary seems to be growing in favor with the Standard. The main difficulty with the companies which previously tried the revolving drill. So we're already talking trash about new technology that we use every day in 1909, the revolving drill versus the rotary. The main difficulty with the companies which previously tried the revolving drill and abandoned it seemed to have been with the drillers. That's right. There's a deep-seated jealousy and half-hatred which exists between rotary and Standard drillers, much like the feeling between cattlemen and sheepmen and the Standard operators, who were put on the rotaries generally neglected them and the work, while genuine rotary men were hard to find. The Standard seems to like rotaries, however, and more will probably be added soon. So as we have had the debate from cable tool to table drive to top head drive, one common theme that we have seen since 1909, it's been dang hard to find drillers, right? So this isn't a new standard. It comes back to our method of teaching. And as we jump into, generations of drillers, and you jump a few decades more and you have a generation that is, sitting hundreds of feet above the ground and working every day. The top left is my father with an Alton Loomis 24 cable tool rig, that he donated to the local cemetery he's buried in. We got the U.S. military running a 50K all over the world to 2,000, 2,500 foot depths. And we got some young hydrogeologists working right now to, define soil. So we can see our generations. And why I talk about 1909 and drillers being hard to find is in our history, we have to know our part and our roots to this. And I think a big piece of this is there are 8.25 million employees in construction in the United States that generate $1.65 trillion worth of business annually. That is a big deal. When you think 25% of that is likely overhead, those dang people that are in the office that never do anything. Just kidding. We all need them as well. But when you really start thinking about this is like $400,000 per individual generating this business. This is powerful. But with that said, 1 in 5 construction workers right now are 55 or older. 1 in 4 drillers is 58 or older. And as we drill down from that 8.25 million, as I've been working with the Bureau of Labor Statistics for almost 4 years now, 1.15 million workers out of that 8.25 operate in an industry that is in excavation, masts, derricks that require drilling. So as we look at these numbers, 14% of the construction workforce is involved in drilling. Now, my driller ego pops up just like Leonardo da Vinci, and that the driller had to dig holes before he realized he needed to build a drill. And I go, wait, civilization doesn't advance without us finding the geotechnical investigation, finding that water, finding those rare earth minerals. That's absolutely our history is rooted in the fact that we drilled it, therefore we could be there. But the insanity of this is every day there are 161 million Americans that work. And right now, there's over 5 million Americans seeking new employment. And that unemployment rate keeps flipping around, but an average of 3.4%. There's 9 million new jobs out there right now. There's 5.5 million unemployed. Right now, the construction industry is adding 30,000 new jobs a month. We haven't seen this since the early 2000s. The average hourly wage is $27 to $28 an hour. So I want you to think, I just said that 8.25 million Americans work in construction. And I think this picture depicts it perfectly. I pulled this from a labor source, and the shading of the construction worker on the end next to, a nurse and the rest of the professionals is 100% our society, right? Like they don't realize how important our blue collar jobs are, how important it is for us to inspire this generation. But here we are, average wage, 27, 28 bucks an hour, average construction wage, $23 an hour. They shaded us out in the value, though we are a very important source. But 8.25 million versus 161 million working every day. More people know people that work at Amazon than they know that are water well drillers. That's tough to think about, right? But that's our history. So I wanted to give you the latest numbers on this as I've updated this over the years. But so where the heck is that 1.15 million? It's 465,000 that really get into what we consider drilling related trades, according to the Bureau of Labor Statistics. Again, if you think about Da Vinci having to build a drill and everything we have going on, we know that we're an important workforce. But today, out of the 900,000 employed in oil and gas, only 109,000 work within a drilling operation. And in that, we have our scientists and our mud engineers and our workover crews and our cementing. In mining, 573,000, 190,000 work on drills or around drills. Then as we look at our operating engineers, it's about 265,000 across the country that, again, work with a mast or a derrick or in an excavation operation. So that is very skewed. So as we go farther down, and as I asked a ton of questions to the Bureau of Labor Statistics about this, we get to 0.25% of that 1.15 million. There's roughly about 15,000 individuals in our country right now that are considered drillers. So we are like the Navy SEALs of the construction industry. We are the top of the top. And that's why the knowledge to share is so important as we get back into this history and we look at how everything's interconnected. It is very much crazy to think about our generations. And now you wonder what happened to the big 200,000 pound pullback machines that we used to be able to develop. What happened to SRAM? As rigs develop, Epiroc and the TH60, there's few and few. At one point, there was 1,000 TH60s that were built within less than 10 years. Where has all the innovation happened? Where are our employees, oil and gas, mining, operating engineers? Because we have training, we have innovation, we have push. We can do that too. There's 14 million water wells in the United States that are private. We're seeing that number actually grow right now. It's very important for us to think about that as we look at our history. So back to the history, off my soapbox on, where we need to go as a industry. And I think it's awesome what Virginia's doing with the apprenticeships and training young drillers, and what your groundwater association has done to inspire new people to get in. And we got to keep doing it. So from 1900 to 2024, what do we see? We see the star drill come on. And man, there are some great debates about star drill setting rigs into the field on no big contracts. Like there is a quote that goes back that they were basically in a congressional hearing over how they got deals multiple times, but that's how you grow. Ingersoll Rand comes on the market in the early 1900s as well, but not building rigs. 1915 with Sanderson Cyclone. So you have Akron, Ohio, and Orrville, Ohio, both building drills. The 20s, we see the Department of Minerals talking about drilling fluid additives. We see diesel powered rotary drill patent submitted in 1925. We see Georgie Failing come on the scene with the first portable rotary drill in 1930. We see the invention of the Marsh funnel, right? What we check our funnel viscosity. We have Hughes with a tricone bit. Schramm, 1950. Tricone patents start expiring 1951. Bucyrus Erie is one of the wideliest distributed drills in the world by 1960. Dick Schramm hadn't even started working for Schramm yet. 74 IR bicyclone, and we're going to jump into that. I think this one's crazy, and we're going to talk also about PDC bits. We talk about these newfangled PDC bits. I was at Ball State in 2008 as we were doing those first 1,800 holes for geothermal, and they pulled out this case of these super fancy bits, each individually boxed, peanuts all over them and everything. These are, I don't know, they were like $8,000 a piece. And everybody was like, we get to use this new technology. And then as I started deep diving in this, I realized that General Electric and their oil and gas division designed the PDC in 1973. So, almost 50 years earlier. Jeffco buys Speedstar in 90. Versadrill starts making an influence outside of just being a rig distributor and supplier. We see early electrical hydraulics in the 2000s. We have Atlas Copco buy IR, and we can go on, and I want to continue to talk about these. But Star Drill, 1899, founded with a building, employees, manufacturing, 50 grand, 15 to 20 employees. And when you start thinking about those rigs around the world, this was their Type C Star Drill 1930 that they suggested you skid mount and pull in with a dozer, and this was influenced by the Seabees. What I love about this ad is as you look at the top, it says ideal for using separate power units, gasoline, diesel, electric, steam. Wait, what? We can't run a drill on electric, Brock. This is nuts. And it's 2024, and Star Drill almost 100 years is going, yeah, we can do this. So, there's the innovations are there. Why? Because we had drillers driving the innovation of the necessity of what we needed. This is a great ad of, defining mining for Star Drill and one of their first powered moving machines. This isn't truck mounted, but again, you can see steam powered. You can see the walking beam. It's, again, look at the design and the ingenuity. 1914, Sanderson Cyclone comes on just up the road, Orrville, Ohio. And what's insane is Cyclone went out and started trying to find the best engineers for drill rigs that were working in blast hole and mining and excavation and cranes, but also the best drillers. And some of that insight came from the ones that wanted to share, the ones that had the best logbooks. So the day I got to go work for Jeffco after I'd drawn drill rigs and CRAN for my dad and grandfather for years, and the first question I asked is, hey, why is this damn throughput at the top head, 2 and 11/16? Why isn't it 3.5 inch so we can do some other stuff? And one of the engineers goes, you sound like one of those failing guys from 30 years ago. So, again, the influence of drills and drillers on how we develop these. So I throw up the walking beam and the cable tool rig. And obviously, if we were in a classroom, I'd see people nodding and we could put our hands up and go, yep, I made it through the cable tool days. But in reality, the walking beam for hammering casing in, for development, for well rehab, for all of those pieces is something that we really lost in our industry. And it was very divine and just a fantastic technology that we shouldn't have let go. And I challenge today, and I know some rigs out there, some combination rigs and others that still have a makeshift hydraulic walking beam that helps do surge blocks and bales and whatnot. But man, that was something that we should have continued. Sure, was the work harder? Is it a little bit of a lost art? Absolutely. But what we could do in being able to surge and develop a sand and gravel formation, unbelievable. Here's a depiction of one of the last cable tool designs by Sanderson Cyclone, and you can see we're moving up and we're a snub nose rig, so we're likely into the 60s at this point. But again, where did this technology go? I added this slide after doing this presentation a couple times where young men and women would come up and go, I don't understand the advantage at all. That's a broken technology, Brock. We just hear about it. We see them parked in the fence row. I grew up running a 22W and a 36 Cyclone, a 43 Cyclone, and then a 36 combination TH60 onto a failing 1500 to a top head drive with Versadrill and so on and so much. What I remember most was one, that cable tool rig burned 2 gallons of fuel in an 8-hour day and all the casing we drove. Site containment was easy. The footprint was small. It was fuel efficient. Had very low overhead. Had high risk, absolutely. And minimal impact to a formation because we were just, driving that stem, stomping a slurry, bringing it out, driving casing, stomping a slurry within a casing. They were simple. I love the fact that in most the Australian drilling manual and several others, they say operate in all weather. Any of us that operated a cable tool in ice or rain understand those friction brakes did not play well with us, but we got it done, right? And we had the ability to stop and go, pull back. We could sample. Disadvantages, that first big cobble or softball or rock, penetration rates, we broke off casing. Casing cost really drove up. We had a lot more cable tools out there until we saw Wheatland steel in Ohio disappear, and we ended up with Korean and Chinese and Turkish steel as our predominant casing. Became a lost art. Again, average age right now is 58, and I guarantee as we start thinking about it, when was the last time you stood on a cable tool rig? And I hope there's somebody in there right now shouting, going, damn it, Brock, I'm still running one today and I love every bit of it. Good for you. And we quit advancing the technology. And how did that happen? First, we had Ray Sanderson pass away, but he left a very strong team. It's not till 1974 that Sanderson Cyclone sells to Ingersoll Rand. So as we jump from there, we got Georgie failing Enid, Oklahoma. Just like Orville, Ohio, and Akron, Ohio, it's wild to think that Enid, Oklahoma has Frank's Machines, which is Speedstar. There's not very much history to be found or photos on them other than the rigs we have in the field. And we have Georgie failing. And at the same time, you end up with Eubanks and the reverse circulation rigs, all in this little town 2 hours north of Oklahoma City that had a demand for water and oil and gas. What I think's cool about this photo, there's one of the first portable drill rigs. Wasn't for water. We were happy with cable tool. This went into the blast hole industry for mining. At the same time this came out in 1930, on the right, that is the first widely manufactured commercial airplane. And the first thing I see, that looks like some upholstery my grandma had in her living room. But in reality, like, think about today as you jump out of a commercial plane, the advancements we have versus what we have for drill rigs. This is water. It's not any other sort of tall boy, everybody. So what I think's neat about failing is Georgie Failing failed twice, went bankrupt before the company came through. But by World War II, when they started building containerized drill rigs, so that we could go and fight the tyranny that was happening in Europe and be able to go across Europe and Africa building water wells. They have a theater that's talking about the war efforts and their next R&D events happening. That's how big failing was at that time. We'd see right here them talking about 270 employees and designing a 200K and a 300K and much larger rigs, all kinds of really cool things happening. And this is 1948 to 2005. We're completely advancing. And at the same time, you have Speedstar, which is the inception of the 30K. So if you look at it, you got Sanderson Cyclone that developed the TH60, and we're going to get into that history. And we have Speedstar building the 30K because Failing is building table drive rigs, and that's how they both advance. Failing dies in 78. At this point, GE and several other large entities have come in and invested in, the Failing brand, which is now used all over the world. I just love this Mid-South commercial that was in one of the big news. They're announcing their purchase of a new drill rig. I wish we still did this today. And obviously, we don't get enough newspapers. But, you think about our investment and everything we do and the importance of this, and then it goes, new water well rig is added by Watson. Outstanding drilling assured. Irrigation jobs invited. It's just our history of this. And this is 1953. Okay. Sanderson Cyclone, chief engineer, Carl Black, he ends up being their president. What's cool is the 1970 TH60. This rig is built for drillers by drillers. Same thing we hear about the 450 SRAM and SRAM coming on the scene a few years later. But their R&D process was, we want a system focused on speed with safety and reducing manual labor. Sounds like what we need today, right, everybody? The rigs were flexible to handle a wide application range and meet individual operators' preferences. This platform goes on to influence the T2, the T3, the T4, and the modern day TH60. What's wild is this rig is so widely accepted, and this is what's building Labe Supply at the time, as they are a Sanderson Cyclone dealer. 1975, Ingersoll Rand makes an offer that Cyclone cannot refuse, but only if Carl Black comes with the TH60. And that's how we get Cyclone's influence on our industry. And we go on to, the twin drill rig concepts that they've worked on and moving past them, and more power, more speed, dual top head motors, being able to self-propel a rig. And that jumps us to, where the heck did Versadrill come out of nowhere, right? And this is no different than Ford versus Ferrari or any of the other modern great stories. And I think it's undersung, but the modern mud rotary, and you can jump on Labe's website. They've done a good job of retelling their history, along with, you can go to newspapers.com, owned by ancestry.com, and you can search endless water well stories from 1770 to when newspapers started disappearing as they put them into an archive. But 1962, Al Labe starts Labe Supply, which is selling building supplies and water well supplies, because obviously if you're going to build a home, you need a water well. And then they got the Sanderson Cyclone rig dealership. TH60 comes on. They start selling them. IR sees the influence of this rig and goes, whoa. And so they look into purchasing Sanderson Cyclone. And so they make Labe Supply a IR dealer for the TH60. From 1976 to 86, it is rumors somewhere between 1,000 and 1,200 drills were put on the market. And you think about any rig manufacturer today, do we know anybody that's building 100 drills a year? No. And so as we look at that, that's a pretty big deal. And then Mark Labe, Al Labe's son, this is Marcus's dad, says, I need a rig for the frost laws, for Indiana, for Michigan, for the Great Lakes states, into the East Coast. I need something that's agile, a little bit more lightweight. We're not talking about going west of the Mississippi. I need something dedicated for east of the Mississippi and the Great Lakes states. And Carl Black, one of the geniuses behind all of this and former president of Cyclone and very big influencer of Ingersoll Rand, is retired. And Labe hires him along with a team. And that's how the V100 was created. And they pushed the limits on conventional hydraulics. And if you think of it from the Racine valve and the Brandon valve to where we are today in electric over hydraulics, and I know there's times where we go, if this was just completely pilot controlled, I'd be done and out of here, or pressure controlled. But this is how we got to what we have today for the agile controls, the efficiencies, all of the rod handling carousels, everything we can do came from a big push by Mark Labe and grabbing Carl Black to ask the question, why not? Arnold Law, who was at Atlas Copco and Ingersoll Rand, also a big influence on this. We have Dick Schramm, we have Weatherby and Wesson at Jeffco. There were plenty of great individuals that were influencing what rigs looked like and how they operated at this time. So as we jump back through there and we look at that last from Versadrill in 1996 coming on very strong from the first V100 of 91, we see electric over hydraulics pop in and fail, right? We all resist against them, and it hurt some major bottom lines and slowed us down. But by 2004, Copco buys IR. We have the last of those black TH60 influence. And what happens? Copco continues to push that line, the T2, the T3. We see them start disappearing. We see Tier 4 come in, and that really influenced the ability for SRAM to be profitable. And we could have went a whole nother time on this and talked about that aspect of it. But we start seeing rigs shrink. We saw Jeffco get sold by Blue T to Aztec, and then they get sold again to Bauer. 2015 is the last 450, and that's debatable. We do know that Epiroc owns the SRAM line now in Australia and is building 665s and 450s, just not for the US. And here we are today. We have a lot of European rig influences coming in. We got some Korean rigs that are out there, and we'll see how that works out at direct pilot hydraulic power. You know, we have to decide what's important, from our repetitive stress injuries to being able to be more efficient and drilling, reverse circulation capabilities. What does the next drill rig look like? Heck, you had a guest speaker come in, Dave Baker, and he's influencing that stuff in Idaho right now because he believes we can do better. We have Derek's in Western Canada building some really great stuff. And again, we still have Versadrill innovating. We have Jeffco Bauer innovating. We have Epiroc doing whatever Epiroc's doing, but they're kicking butt in the blast hole market for sure. So conventional rotaries. We got a table drive right there on the right. We got another Versadrill on the left. Gets us into the rest of the history of drilling, and that's basic borehole creation. You know, we have feed pressure exerted by the drill rig. That's what we need, right? Rotation turns the bit. That feed pressure, when it was table drive, was bit weight, right? As we get into top head drive, we have more pull down. We have that rotation. We saw the rotation advancements from 120, 130 RPM to 250, 270 we have today. And then we have to pump a fluid down the hole to remove those solids. So with that, bits, when did that first bicone bit come out? When did tricone? We saw that tricone's patents started to run out in the late 50s, early 60s. But Hughes, as we watched the movie Howard Hughes, what's it about? It's about airplanes and movies and not a lot about the oil and gas market. But that entire family's fortune was built in the oil and gas market by understanding how we're going to cut, hydraulics, what our cutting speed's going to look like. So here is Spindletop Lucas Oil Well, October 6, 1902. October 1st, 1899 was the start of the first Lucas Oil Well, the only well there. What was introduced and proven? Rotary drill rigs, viability and technology, 1901. Hughes bicone bit, 1901. Drilling fluids. And from a Virginia influence down to the Jubilee, a kid growing up in this industry, getting to know Carl Mason and having him on our job sites and whatnot. And I talk about Carl and the Sam Geffen and Jeff Blinn and Ron Peterson, the OG mud engineers for Bayreuth that knew a lot of the history. These guys had all told me that drilling fluids were invented at Spindletop, King Oil Ranch, out of a slurry pond right there. And we're going to get into that. So history of drilling fluid. Spindletop, we're having issues with sloughing. No clay, no mixer. There's a pond nearby. You can go to the History Channel. You can watch the video that shows the drillers or cowboys chasing these cattle into a great big pond that they called tanks down there. It stirred up the red calcium clay, bentonite, and started making a slurry that helped for the sloughing off. It's a really cool historic story. They ran them in there. We got a slurry. We stabilized the hole. Just shortly after that, 1,000 feet, 1,043 feet, actually, we hit the first high volume oil production well. And you think about it, King Ranch, Spindletop, King Oil Tools, there's so much that comes from that. But Lucas Oil, if you're a Colts fan, Lucas Oil Stadium, you're a racing fan, yeah, this started a lot. And so we said the inventors of drilling fluids were cows. And before you get upset and kick me out of here, we're about to talk about Albert Fauck, F-A-U-C-K, who is a rig inventor as a driller. And why is he important? Because as we were in turmoil in the United States, the Europeans were advancing rig technology. And we had him and Anthony Francis Lucas. So we talk about proud Texans, Anthony Francis Lucas. No, he's Austrian and German. But we had the Bach Express 1833, which looks very much like a mechanical driven cable tool system that's allowing us to crush. You can see the jars and how they were using the augers to push. This was happening in 1833. Rotary oil wells with tubular tooling made of steel, 1840s in France, Germany, Austria. First drilling fluids used, water, brine, clay, sloughing holes, Western France. Who was there? Albert and Anthony. And so it's cool because you know what? Ellis Island, all of our history, we all have some Western European history and whatnot. There's an influence to everything that we do today that started with these guys. And this is a photo from Spindletop. This was from the driller's log. Our crew, composed of veteran drillers, experts, had a rotary system and was already acquainted with utilizing of drilling fluids to bore for water. In October 1900, they started drilling and soon hit quicksand and thickened the fluid with clay. Think about it. Here it is. We don't have mud engineers yet, and we're already saying, hey, thicken that stuff up. They started drilling. They hit quicksand. They thickened the fluid. They're looking for filter cake. That's what we're calling that high ground plasticity. And they stabilized the borehole. The site started producing muddy fluid, which promptly lined the hole, sealed off the quicksand, and solved the problem. At the start of the drilling, they would circulate the fluid intermittently. The crew would stop the rotary drill at regular intervals to allow the pump to send down fluid to bring up cuttings. They hit oil 1901, January 10th. From there, as we look, and man, you can tell that was some hard work there. We get into advancements in oil and gas technology and rotary technology. And as I started working with Bayreuth, this was one of the slides that they would update from the Halliburton side, the security, DBS, wireline, everything that we're working on in technology wise. But 14 wells in 2008 with an average of 58 days apiece. And then you can see we start reducing that. And at this time is the influence of drilling fluids, bits, technologies, rack and pinion, better abilities to understand what we're drilling into, engineered fluids to in 2016. And that's where we really started seeing a slowdown, 3 wells, 29 days apiece. And today it is not uncommon to be able to do 1,000 feet a day. And why? Because of the unlimited resources that were put into technology, logs, equipment, and the science. And it all comes right back from Spindletop and Albert and Anthony and their influence. What else happened? The bicone bit, which was used on that rig by Hughes, Sharp and Hughes Tool Company. And they don't get a patent for this thing until 1908. But this is the bicone. What I think is really cool about seeing this patent, as you see, there's jets, those washers that you see right there. So all of the debate about the dang oil field has made it too complicated and all these bits just were washed out in the beginning. No, we always needed that high PSI at bit face to push the fluid out away from the bit and up the hole so we would have a longer life. That brings us into the tricone bits of mill and button and the importance of those. And from an educational standpoint, the new guys and gals in the room, what do I need to know about tricone bits? One, they are dang tough. But the second thing I want to think about, as I look at a mill tooth bit with long teeth, like the one on the far left, that is no different than your front teeth. It's going to cut soft and medium soils. And no different than if I was to bite an apple, I'm going to have big bites. So I'm going to need lots of rotation to break that up. It's going to send it back to my molars, and then I can swallow it. I don't choke. Tricone bits are like our molars. They're designed to crush medium and hard things. And you can see as we have the teeth progress in size and hardness, how we're going to cut. And again, so as I'm looking at what does a mill tooth do? It takes big bites, like the front of my teeth, a button bit, little bites, my molars, both. I don't want to choke that bit, right? If I choke, I can't survive. If my rig chokes, we don't get the hole in. So 1933, the tricone comes in. Why did we go from a bicone to a tricone? If you notice on a good tricone bit, the head cone has that extra long piece on the inner side of it. And what that is that is the first point of cutting. So that is cutting the center. And then the next cone cuts outside of that and outside of that. You can see we still have jets. Also, in this patent, what does it say? It's talking about reluctant force, what our efficiencies are going to be, what our weight on bit is going to be. There is a calculation out there that tells you how much weight PSI I need per inch size of a bit. And as we get into a 10-inch bit, we're looking at, for a good bit weight, 6,000 to 8,000 pounds. So I want you to think about that the next time we set up and we throw one stabilizer on there and then we start putting tools. When did that bit really start cutting? The deeper I got, the more rods I had on there, the more pull down I put on there. That wasn't how we were designing tricone bits. So you can see Hughes is credited with creating the tricone 1934 to 1951, had 100% of the market share. Second generation pops in. He wants movies and airplanes and insanity, and we've seen the movie. Starts spending that money. But What did we get out of Hughes and the Tricone and the technology? We have Baker Hughes, drilling fluids technologies, still an advancement there. To today, as we look at modern drawings, and really this is a drawing from 2010, but you can see this was a Tricone designed specifically for air rotary for foam. Look at all of the extra inserts, gauges, everything. All of those initial points of strength and the sealed bearings from unsealed bearings that we had on the first cones, looking at the cutter heads, looking at the additional air slots to be able to push cuttings away, all the things that create heat, create issues at bit face. We have over the years looked at these bits. So as we pull that bit out of the back of the pickup truck and we're thinking about buying it and it got retoothed in the oil field, if I see a lot of buildup on the skirting, that's protecting where the bearings are going to be, that is a poorly jetted bit. It's been used poorly. Bits should wear out at the bit face and teeth, not at the skirts. And that's why we have the jets and the flow and the velocity. If not, we're creating that heat. That in this great photo right here. That's what I want. I want a jetted bit. It's keeping those cutter heads clean, moving that fluid away from the bit face. Polycrystalline diamond compact. For a lot of us, we think it's 25-year-old technology, including me as a young 27-year-old, 28-year-old mud engineer at Ball State going, oh, wow, the oil field's only been using these for 10 years. Not true. PDC cutter head was invented by General Electric in 1971. Why? Because downhole hammers and cutting that dense rock was increasing the cost of exploration. And so as they started looking at an alternative, it was, could I get higher rotation and have one engine with less air pushing to be able to clean this borehole than if I'm going to be running a 1600 CFM compressor along with the rig and the rest of the support equipment. So it was all about finding a more fuel efficient way of drilling. So they started in 71 looking at diamond heads. Mind you, at this time, GE is involved in space and jet engines and trains and the electric and our refrigerator and televisions, and all the way up into when Jack Welch in the heyday, they owned NBC and Seinfeld. So, I mean, all over the place when you think of what GE's influencing. But they spent 3 years doing R&D and just smoking bits. And then in 76, they had a pretty efficient system. And you can see from 1980, the adoption, how much tricone's used up to 2004. I have not been able to find a better graph than this, but I can tell you today, depending on our formations, one, we have drilling programs that are 100% set in a bit trip. We're going to run that tried and true tricone to X depth, and then we're going to trip out and we're going to go in with our PDC because we all like to think it's called pretty darn costly instead of polycrystalline diamond compact. But the idea is to get the most bit life possible out of these. And you can see, and I ripped off the photo on the right, but again, what happens when we get in unconsolidated and broken rock, we quickly start busting those teeth and making that cutter head inefficient. You can see on the left, that was caused by heat. And the more heat buildup, those cutter heads just want to fall right out. So as we advanced our drill rigs and we got good at top heads and what we needed there, we started looking at cutting size and creation and what method's going to be best for us. And that's what we're going to jump into with drilling fluids, right? On the far left, we have foam on an 18-inch hole, bringing out pretty big cuttings in Austin, Texas. We have in New Mexico a blue-green shale that we're drilling on straight air. And we got a mud rotary hole somewhere on the East Coast with just a mud pan, all efficient ways. But what engineered solution did we put in place to make that work? So as I think about our engineered solutions or when we have to solve those problems, What are we looking at? We're looking at the type of geology and soil we're getting into, the soil formation hydraulics, and that's where drilling fluid equivalent circulating density comes in. What are our downhole pressures? What is our depth to water? All things that have influenced how we've designed equipment and gotten to today. And then what is our available capabilities of our equipment? That rotation, that's going to determine if I can run that new PDC bit or that new bit with jets. What is my pullback? What is my pull down? What do I have for capacity to move those cuttings away from my mud pump to my compressor, to tooling, to bit selection? Again, what size cutting am I going to create? What force am I going to create on that borehole? How do I minimize that impact? That brings us into drilling fluids. We're classically trained mud guy. In the beginning, we had National Lead Baroid and we had Magabar. Magabar became MI. National Lead became Baroid drilling products, which ends up becoming Dresser Hughes, another Hughes influence onto Halliburton. But where did it all start? The Bureau of Mines in 1913 and 14 started thinking about, how we could maximize our fluid usage on using these sodium bentonites and clays. The first changes were made in the 1920s, and that was from a gas kick or artesian flow, and that was using barite weighting material. Fun fact, National Lead Baroid comes from barite, which is barium sulfate, which at the time had a specific gravity of 4.2. Water has a specific gravity of 1. So, as we weight up to hold back artesian, why we're using barite weighting material, it augments our drilling fluid to be able to hold back that head. First commercial drilling mud company was Baroid. Fun fact, at the time, they were selling barite into the paint industry as an additive to paint for walls. Probably not the best idea for what we needed it for, but people were buying it. And then by the 30s, we had mud engineers. And by the time we get back from World War II, mud engineers are widely used around the world. One of my mentors is the back of this pickup truck. This is me on my internship with Baroid in the early 2000s. But, you knew you were in good hands when, if it was a Baroid or Setco or Wildben or MI or whomever showed up, opened their back of their truck and pulled out so we could start looking at fluid viscosities, filtration control, rheology, understanding what's going on. A big piece to drilling fluids past World War II wasn't until we got into the Clean Water Act, the EPA, and then NSF, the National Sanitation Foundation, which we see all of our drilling fluids with a standard 60 and 61 designation, which really came on strong early to mid 90s. But why? Because we needed to know what we were putting into the ground. And I want you to think back to guar gum and xanthan gum and some of the other additives we had, or the fact that we rehabbed wells with tripolyphosphate. And we know that phosphate feeds microorganism and lets them grow because it's a nutrient source. Same reason why we've stopped using phosphates in soap. But again, that all came from the Clean Water Act and us understanding what we could put into the ground and make a good potable water well. Think back to 1100 BCE, the Chinese had documents saying, this is how we protect our groundwater. This is what we should do. We shouldn't clean livestock and animals around our well. Those things came from Christian era for us. It's wild. There's, it's in the book of John where Jesus meets the woman next to the well. I dang it, I can't think of but anyway, we talk about this as the point of meeting places, but in wellhead protection, it was very important. So, jobs of a drilling fluid. As we think about this, we needed a drilling fluid beyond water that would help cool and lubricate that bit and tooling. Same thing we had at Spindletop. We needed to maintain borehole stability. We needed it to suspend cuttings. We needed to have drill cuttings removed from the hole. Suspension of cuttings started showing up in Spindletop in 1910 to 1920 because we started going deeper and we needed to be able to bring out some of those more aggressive shales that were staying intact, that were heavy. We need to minimize the fluid invasion of the formation. That's exactly why we pumped that calcium bentonite in 1900 at Spindletop, was to make a wall cake and stop the sloughing and to maintain flow. So we got our old school graphics, and I'll see if I can get them to work. Here we're drilling. We have straight water. What's happening? That fancy PDC bit's heating up. We're destroying those cutter heads. We got bad stuff. We get some fluid. We keep the bit face clean. We stop all that heat. We're able to maintain. That all came from somebody going, wait, what if we could pump something more than just water? We know that water is just not a good lubricant. Sloughing, we needed that borehole stability. We made filter cakes. Suspension, and it didn't work. Oh well. This is one of my favorite. This was built by Jeff Blinn, Bayreuth guru, and I look at this and the wall cake and everything that is, being able to stop that porosity zone, that sloughing. That was a big advancement. And if we wanted to go even geekier in the geology standpoint, volcanics, 100,000 years ago pushed all of that bentonite to the mid-con, into the Dakotas, the South Dakotas, into Wyoming, and planted it there, and it sat in a prehistoric sea for hundreds of thousands of years and beneficiated that clay. Our country comes together, Pangea breaks apart, we have continents, and suddenly we have, a 100 feet down, this rich sodium bentonite blue and Newcastle yellow that we use. As blue is our grouts and chips, and yellow is what we use for our gels and drilling fluids. So we could even go deeper into that, but that's those are the useless Cliff Clavin facts that I have when it comes to drilling history. So as we look, what was our biggest goal? We needed to understand how to drill fragile formations and prevent that fracture gradient. The deeper we got, what happened? We had more pressure that exerted to the outside of the borehole, and we needed to be able to stabilize that and bring cuttings out. We jump beyond, and it's crazy because I just saw a patent come across, but National Lead Bayreuth had been working on a computer system that could do mud weights, and you can enter everything in. And we ended up with a drilling fluid program system that we could put in parameters. And we've seen Mark Whittle and many people across the country use this on our sites. But there was a point where we were going to be able to take a mud sample and run it right in and nobody touch it. But the same as electric over hydraulic didn't work twice before it started working for us. What do you think a drilling fluid did going into a computer that were insanely expensive in the 70s and 80s? Today, there is a company out there in Australia called Mud Logic that's doing this. And I'm excited, but at the same time, one of the reasons I'm attracted to this industry is nobody gets mad at me for playing in the mud like I did in my Sunday to school clothes back when I was 4 and 5. So jumps us into drilling fluids. Where do we see this documentation? Where do we start talking about creation? Groundwater and wells is our quintessential industry book. And what does that mean for us? We're on the 3rd edition. We need to challenge those folks at Johnson and the industry to come up with a 4th edition. We have the Australian Drilling Manual, but that's still the latest edition. It's 25 years old. We have other manual water well constructions. The Missouri Water Well Handbook is now blue and is a countrywide. I was surprised. Good job, Missouri. We found something that came valuable out of there. I'm sorry if any of you I'm just kidding. The Halliburton Red Book's digital. I love the Halliburton Red Book. It's something that I keep in my trucks, and it's fun on the scholarships. We still see those things, raffled off. How the heck do I go from drilling rigs in mud and some guy with a last name that really sounds like an inappropriate word to NASA Control Center, 1973 versus 2000 or 2023. And you can see our technology and our advancements and the reliability. And this is what I want to talk about. The GRACE satellite program. And we're going to talk about how technology influences our drilling and what we do today and the advancements we have. But in 2006, we started the GRACE initiative that is mapping mass of the Earth. And let's face it, with the exception of a little bit of tectonic movements, our land masses aren't moving, but our water in form of glaciers and rain and flooding and extreme events, along with groundwater, are. And we can see the shift in mass. And so we have a lot of data coming out these days from GRACE. And that stands for the Gravity Recovery and Climate Experiment. This photo from GRACE is from this month. And this shows, you can see the purple up there as our glaciers, and you can see our big points of water and what's influencing us. But as we come out with this data for the Western United States for the Colorado River, or we look at what's happening in Texas and Mexico with the Rio Grande, or Cape Town, Africa, Caracas, Venezuela, all these water stressed areas. And NASA's been saying, hey, since the first time we sent somebody up into space, we've been those. So, we're talking 5, almost 6 decades now of us having men and women going into space. And as you look down and you want to go, hey, I can see my house, and you start seeing those plumes of pollution, the EPA, the Clean Water Act, the pollution influence on the Cuyahoga River that caught on fire in the 70s, NASA saw it as we were going into space. And so now we have dedicated technology, and we do it with the German government, who helps with our data retrieval. It's a joint effort. We're using the German Space Center as well. But, this is a May 2024 study they just updated, but it's showing our precipitation, and it's giving us from 2000 to 2023 data. And so as we move into history and we see this strategic water plan come into place by the White House, which I don't think we need. I think we need to keep our groundwater and all of those policies within our states and be able to work together. We are seeing what's influencing us today. And as hydrogeologists and scientists and drillers, we just need to know how we use this data effectively. So if we jump from everything's a hammer, let's get muddy, to technology, we don't want to get muddy. What is your company using today that's influencing your company's history? GPS. I GPS every well that I'm on. I love to talk to a project manager as I'm about to drive out to that site and go, hey, have you been out there? And they go, nah, I jumped on Google Earth like they're Jason Bourne. And that's a true update that shows me where the bees are and the new fence and the big mud hole that is right there that we need to mat. So we have some limitations to our technologies, but really, like, when we think about our GPS, to our smartphones, being able to have logs, being able to communicate, being able to put a video on in real time and talk from the office, to our tablets interacting with our customers, our digital forms, emails, texts, our customer engagement, our employee management, how we're able to see telematics and trucks and whatnot, how we project manage. We see all of these pieces, including social media, or the fact that we're doing a 2-hour CEU right now, and I'm in Kalamazoo, Michigan, in the technology that influences us, talking about history. And for me, data retrieval. As I think of my grandfather at Yordy and Son Well Drilling, to my father, and all the logs, the handwritten logs and the things that the state of Michigan are, now updating, but all of the estimates that were on tricolor, carbon paper and whatnot, how much of our history is in a filing cabinet that is one generation away from being able to be shredded? Because you know what? Grandpa and dad told me to put this in the loft of the barn, and now it's covered in bird poop, and it's time to just throw those things out. And you know what? What history is there? Going back to looking at the trends of how did we raise prices? What influenced us at 9/11 when prices and the war on terror started? How did that influence our work, or the housing market crash, or even COVID? And there's plenty of others, from the fuel issues and the Iran Contra and all sorts of things of data retrieval that can help us know where our company's been and where we're going to go. With that, we've talked 1900 to 2024. Computers came on, 74 years after our first talk of the Star Drill. And you can see, we're excited about IR buying Ingersoll Rand in 75 when Microsoft is established and Apple is being established. And in 1980, there's only 1 million computers worldwide. If we jump over to the other side, 1989, there's now 100 million units worldwide. AOL starts. AOL in 89 had 100,000 members. In 1998, had 14 million members. There's only 14 million private water wells documented in our country right now. To put that into perspective, the same as I talked about GE and PDC Bits and Jack Welch, they knew AOL was a formidable, technology that everybody was on, but Seinfeld was more important, because at the tippy top of 14 million members at 9 p.m. on the East Coast and 9 p.m. on the West Coast, AOL saw a drop of 95% when Seinfeld came on. And so, you think about how we look at trends and we think about nuances of drilling a well, for somebody to correlate that data is kind of cool. In 1993, there was only 130 websites. Some of you drill companies are still using that website from 1993, aren't you? No, I'm just kidding. 95, 38 million households with computers. So now we have doubled what we had in private water wells. We have Google in 98. I'm going to jump over to 2010, 4.7 billion cell phones in the world. 2 out of 3 people in the world had a cell phone. At the same time, a study came out by the World Health Organization that 1 out of 3 people didn't have access to clean water in the world. That's where technology has escalated, and what the importance of water and drilling. And let's face it, you don't have 4.7 billion cell phones without the rare earth minerals being defined and drilled by our rigs. So we jump to 2011 to 2024. What do we see now? We have precise location. We have VR that's going to affect the way we are able to train a new generation, being able to get them muscle memory on a control panel while they wear a visor, so we can mitigate those risks. The amount of data we can store. I have a camera that I took photos at your show all the way through the Jubilee, and I just threw it into my computer, and it's a 225 gig memory card. And I've jumped on and grabbed the photos I've needed, but I hadn't offloaded it. And I was at 225 gigs. And I'm an idiot for just leaving all of that in one spot. But, that's where we're at when I can remember going to college and having a floppy, right? So we have progressed fast. I want you to think about how we're using this in our industry. And my buddies at Matrix, handed this off to me. And I don't know if we'll be able to hear the audio or not, but we don't have to. But this is the future for being able to train and being able to visualize, because let's face it, we have a generation coming in that may have never sat at the dinner table and listened to dad and grandpa and mom and aunt and grandma all talk about the business. And so we need to be able to explain and talk about, how drilling works, how a bit encounters, and especially I'm going to talk about reverse circulation because you know what? Reverse circulation patent, everything started in the United States. It didn't start by some crazy Austrian with a bad name for a last name or any of that. It started right here in the United States with the patent and the influence. And that's how we got the Jet A and all of the reverse machines and techs we have. But you can see if we can explain it in a different way and look at the interchanges and how a borehole interacts, how can we teach the next generation? So, reverse circulation drilling. We did it. We did it here, and there are a lot of great Virginia Groundwater Association companies that run RC. And the first patent came in 1957 from Bowles. And it's pretty cool the notes that he had that said he was issued a patent for drilling system that employed reverse or jetty circulation. At one point, we were going to call it jetty circulation. I think we should start a campaign and go back. I kind of like jetty. Nah, I don't RC, I jetty. That's pretty cool. This method used a hollow drill stem, but instead of pumping the water down the hole, I have this thought that he gets home, he's talking to dad and grandpa, we're cable tooling, we're doing successful. Maybe we got that first rotary rig, and he goes, "Hey, I don't want to pump drill fluid down the stem anymore. I just want to flood the backside I want to drill the first 40 feet conventional rotary, just rotary. And then I'm going to flood the backside and I'm going to create a negative pressure that's going to help me pull the cuttings up through the center. And there's going to be no force to the formation, and we're going to drill more productive wells that doesn't have that 200 psi at bit face forcing drilling solids out into that porosity zone. We'll be able to develop faster." And I can imagine dad or grandpa dropping his fork into his mashed potatoes and going, "You're an idiot. What have you been ball at night and listening to that new obviously not, it's 1857, but in my mind it's the 1950s, and leave it to beaver age of this. But no, it is pretty cool that he goes, "No, we want to pump the fluid on the backside and allow it to return to the stem." And that's how we get the designs and the side discharge and whatnot from where we are today. So we can claim that one. And to that point, as we progress, solids control, the influence of drilling solids control all started in the United States, from the Mudder Goose to many of the units that we have out there to our small portable units of the Mud Puppies and Mud Slayers and whatnot, all influenced here in the United States first. Readily dispersible polymers, though those very first dispersible polymers came from France and Germany's polymer facilities. Again, it was American employees at Bayreuth and other oil and gas companies in the US based, Houston, Texas, that influenced us. And any of us that remember buying bagged polymers and having to run them through a jet hopper and plugging up and seeing those fish eyes and the dollars, and me having to say to my father, "I understand this is a $300 bucket and it looks like most of it is sitting on top of the mud pan and not going through our circulation and being part of our fluid system," is hard for innovation. So, readily dispersible polymers, a big deal. Gold series for Bayreuth. Concentrated foaming agents to be able to do more foam, to more digital databases. I was talking with students on Monday and Tuesday, and they said, "Hey, Brock, we don't need to do the drilling math today because we have an app for that." And then I had to get to feel like that curmudgeon 44-year-old and go, "Everybody give me your phone right now." And I made them show their work. I felt like my math teacher. I should have made them put a paper bag on their book as a book cover or something silly. But we go from drilling apps to 5G. Our ability to communicate, our ability to get logs, to our webinars like this, to NGWA's University for Drilling Basics Online, which is a heck of a resource to be able to get people involved. All of the digital archives of presentations from NGWA to thedriller.com to this one's being recorded for Virginia right now. All of this, our data is king. So sharing knowledge today to progress this industry. As we look at, there's 15, 16,000 drillers out there. Who are we going to train? It's going to take some interactiveness. What else should we be using? In situ. Any of our transducers that come with a wireless modem, our ability to be able to do those test wells. It's wild because I was on a project in South Carolina, and the geologist on site, his PG instead of professional geologist, was pretty grumpy, and he wanted us to do hand water measurements as we're doing this well. And he said it's for redundancy and it's the way we do it. And Groundwater Wells book version 2 says this is the best way. And I said, I can get instantaneous results and we can chart it. We'll do it both ways, but I'm going to have it with my, water level meter and my transducers and my sounding tube. And at the end, as we mapped it out on my laptop sitting there, he goes, "Hey, can I get that data?" And I go, "You're not done getting your hand measurements yet. We got to make sure we get all those." I didn't have to pick on him back, but what we can do and see and map shows that our tribal knowledge is influencing what the life of our wells are. And we know that our experiences, knowledge, our investment in our equipment, our art, our profession, everything that we're doing shows what we're able to do. But being able to have a digital map just proves it. And it's one thing that, it's great. I have a great background in hydrology and geology and whatnot, groundwater science, but again, being able to stand on the back of that rig and have those nuances and understand what I'm drilling, that porosity zone, and then being able to, at the end, throw in and be able to monitor it from anywhere in the world just goes, look at what we can do. Safety technology, it's been hot, right? Every conference I'm at, I say, go to the App Store, download the OSHA NIOSH heat safety tool. We have a national heat initiative right now through OSHA. Why? Because we have young men and women who are collapsing and have died on projects, and not all drilling projects or construction projects, but in farming and forestry. But I was with the team, and maybe my camera will pick it up, out in the field on Tuesday, and I pulled up the app and it said, feels like 109 danger. And the 15 students in there, 2 of them had it downloaded. I said, everybody download it. We opened it up and we looked, and it talked about the precautions. It talked about what the signs are. It explained where we need to be and seek. But extreme heat, extreme weather, these severe storms, flooding, all of that, when it comes to our history and technology, the NOAA app, WeatherBug, the heat indexed app will help us. And it helps us understand that we need to take more water breaks, that if one person's thirsty, we're probably all thirsty. If we're thirsty, we're a quart low. But there's many pieces of mitigating risk. And this is a very simple technology that makes our business better and keeps us safe. Again, in safety technology and using our smartphone, the sound level meter, SLM, the NIOSH OSHA sound level meter. If I'm going to be working in an urban market, if I'm going to be working on a project that I have a lot of neighbors, I just want to know I can download this. Most of our smartphones at this point, and the app will tell you, they're almost calibrated as well as a sophisticated machine. Obviously, the safety police want to tell us that we need to go out and buy that dedicated device. But again, the chips and the processors in here have shown us that we have the capabilities. So how can I influence my company with history and technology now? I can have this meter and I can show that when I'm 30 feet away from the rig, I'm less than 85 decibels and I shouldn't be affecting my neighbors. Just things that we need to think about as we have more people working at home, and noise mitigation. To the same point, my father with my children before he passed, he would get down on his left knee and would um, you know, basically lean in to listen to my children with his left ear because he ran a rig with the operating controls that the helper side was on the far right. So his right ear was shot, so just from a hearing noise mitigation, this is technology we can be using. Uh, Wristband technology, lone worker technology. We obviously we have smartphones, we have telematics, but if I'm a pump company, I'm in a situation, working around, it is wild to think about the ability to go open up a control panel that could have arc flash, not in arc flash gear, and not have something that's telling me that I'm working alone. So what does your journey management look like? What does your safety look like? For us, our history and legacy of our business is the way that we are able to take care of each other and our people and all the new technology. So being able to have a wristband that says Brian's still moving, or oh, look, Brian spent 2 hours at the coffee shop. Obviously it comes back to being able to be safe and knowing if we're going to work alone in high risk conditions, what can we do? And these are cool because they can have the like help, I've fallen and I can't get up, old lady type button, or you can record that near miss recording and send it back. But they can get to the point where we can talk about straining, from ergonomics to falls to movement to heart rate. They're getting cheaper and cheaper, and it's something that as a company we should be looking at. Water scarcity, security, sustainability. Um, every major news publication out there is showing water rationing and what's happening. And from a history and data, because of the GRACE program and the hydrogeologists we have out there, and how the White House is looking at a strategic water reserve, it's the first thing that I'm against. I 100% see NGWA in there making some influence. We all that discussion on our state's water and how we treat those rights. But here's the deal: Texas, really California first, Texas, Florida, three most populous states in our country, the most House seats. So as influence comes into strategic water and who can influence policy, it's very much about the data we know and how things are being impacted. You can see those gray areas with the Ogallala and New Mexico and whatnot. So if I'm a company and I go back to Bowles stepping in and saying, hey, I think we should pump fluid on the backside and create a reverse, what prevents us from progressing our legacy and our history and adopting those technologies? And part of it's, the expense. And if I think of a PDC bit, even at Ball State was, 8 grand. uh, we thought they were brand new and they were expensive, and we had to treat them appropriately with the right bit weight. We needed to use the manufacturer's specifications. What is the complexity to that technology? What is it going to take for our team to be able to adopt it? Are we at the senior level going to adopt it? How is it compatible with the existing software and systems? Filing cabinet covered in bird poop in the loft is not compatible with QuickBooks and what we're doing today. How do we get back there? Our resistance to change. I'm going to use this sputter. I don't need reverse circulation. Or let's listen to the crazy Austrian and German about pumping drilling fluids downhole. There's security concerns when it comes to if I sign up for this data or if there's a breach or a myriad of things. But in the reality, if it fits your business, you have the influence, just like the TH60 to the Versadrill, to make change. And the same as, Star Drill to Cyclone, from cable tool to rotary rigs to Georgie failing, saying, why not? We need a blast hole rig that can move faster. It's about the necessity and how we influence. So as technology comes out in our industry, from our distributors to manufacturers to colleagues, we need to be able to give the feedback. As we look at Chauncey and team with the NGWA board come across and talk about, groundwater pro or a business pro, you know, there's still things that need to be influenced that from the days of Well Magic and Rick Oberly to today of what we have. It works when we adopt it and we use influence. And that influence can't be a 2-foot pipe wrench just smashing it. Sometimes that works, but not a lot. So how else can we adopt technology? We talked about those generations and we talk about the oldest drillers being 58 years old. We have Gen Z coming in, and I'll tell you what, they've had technology from the beginning. They understand smartphones, they understand processes, they understand what we need. So as I'm looking at my business and my legacy and my history, what I want is this ability to document as many standard operating procedures as possible, document my safety, document the tools that I need for each job, make that list. Those are things that as we have that Gen Z coming on, we have that deeper hole we're drilling, or we have some time because we have extreme weather. Let's get them using their data-driven mind and harness it and make our company better. And how are we going to do that from a collaborative process? Check your ego. I know that to be a good and competent driller, we need to be able to make microsecond decisions. As we go to pull a pump, as we assess a situation, a hazard, we need to be able to make good, solid decisions and trust them, trust our gut. That requires ego. What doesn't require ego? Our collaborative process. So I go, check your ego, Brock, check your ego, Brock. But in reality, what I want us to think about is we drill boreholes, not people. And with that in mind, we need to start conversations with our new team members, with our new drillers. That moment that the phone call calls and we hear the bit is plugged and we don't know what to do and we're tripping out. If I was standing on the platform that minute, none of this would have happened. What did I solve? Nothing. Because the only way I have a more grand history of my business is being able to step off that platform completely. So defaulting to trust, sure, there is a time we need to get back to the after action review and talk about what happened and why we failed, but it's not in that conversation. What were the methods that got us successful? What is our success rate? We need to talk about consistency. And if this is the way the company was built, those are the methods we need to go with. My nickname, as I got to be a young rotary driller, was Brock Smash. Why? Because I knew I could run that first drill faster than my dad and grandpa. And I did. I also learned that I could turn a Johnson screen into a compact slinky. And though I was able to go faster, we didn't have any better of a well. But just like Bowles or Black with the TH60 and Sanderson Cyclone, we can question everything with an open mind and think about what our next methods are going to be. We can share those best practices and methods with each other. Everybody that's on this call today or that goes and we sit and we have dinner together and we laugh, we can build ourselves up because there's 455 million bore feet to be drilled in geothermal right now on the East Coast. There are more water wells being built. We're seeing legislation to be able to drill water wells in areas that have municipalities, as we saw with our friends in Georgia. And the Carolinas are fighting that right now. New Hampshire has a rule that if you have, Georgia started this, if you have more than an acre, you can drill your own water well. Well, the homeowner can't. They need a licensed professional, us, but you can have a private water well. You don't have to be hooked to a mandatory hookup. How do we do that? We shared our best practices and methods, and we trusted the science, and we let the science trust our guts and instincts. We all took our experience and built better knowledge because in drilling, we're discovering the unknown together. And as we think of bowls with reverse circulation to Hughes Senior going, bicone works pretty good, but we're deviating. What if we had one more cone that helps us center the bit? It's that divine. So this is our wrong adoption process right here. This is a bad Dr. Seuss book. Well, we got about an hour and 36 minutes in here. I'm open to questions if there are any, Christina. I am very respectful of it's Thursday. I'm sure you've promised everybody that we should be done by noon, which really means 2:30 or 3 on Friday, because we're all uh maybe physically there tomorrow afternoon, but we're mentally on a boat, at a grill, on a golf course, celebrating our day, Labor Day. So if there's any questions or comments, I'd love to take them.
Thank you,
Or
Brock.
maybe we can't.
Yeah, no, thank you, Brock. We'll maybe take a minute and see if anyone unmutes or turns their camera on. Great content. Appreciate it.
I appreciate Virginia groundwater, and it's always fun to get to see you all and hang out, and it's great. And I do want to say, as a Bayreuth guy and whatnot, being there with Dennis Duty and Jeff Quinn, and then Jeff, you know, not too long after that, no longer being with us. He was a damn great mud engineer and a good friend, and that sucks. And again, all of the knowledge and history and his passion for teaching and all of the experience from Lane to Bayreuth to other polymer companies, that's exactly why it never happened unless we wrote it down. And I think the other quote is the faintest ink is better than the strongest memory. And sharing that knowledge is very important for our history.
Absolutely. Yep. And that's one of the objectives is with this virtual track is to hopefully, record and have this resource that people can come back to. We've got great content from other teachers from the past years. And so I'm hopeful that we'll continue to do similar education.
I just expect my 15-cent check every time you view it. Like I'm just kidding. Seinfeld reference.
I'll be happy to. Well, did anyone have any questions or any comments regarding Brock's presentation this morning?
Hey, Brock, this is Jay Royal over here at Cinder Hydro.
Hey, Jay.
What a great presentation you got put together. Hearing the history of this and how far this reaches back, and that you took the time to put it all together. Really interesting. I look forward to looking at this again.
There's so much more, and as I dug, I wanted to pull some from Johnson and Roscoe, and I just couldn't find the right content. I really the 450 SRAM, the 450M, we used to joke instead of mud meant Michigan up here in Michigan. And I wanted to have more history on how that influence happened. But again, as big companies buy little companies, and then things get archived in a filing cabinet with pigeon poop on it, it's gone.
Right. Gotcha. Well, it was really informative, really interesting. I can see that people without a drilling background could find some real enjoyment in seeing this.
Thank you.
All right. Well, thank you all. Thank you again, Brock. And this does conclude the virtual education track for the Virginia Waterwell Association. I appreciate everyone joining us this year and look forward to seeing you at one of our future events.
Thanks, everybody.
Thanks a lot.